Welcome back. We're doing a new section in geometry. It's 1.5 in your textbook, and it's about angle pairs. So instead of just individual angles and naming angles, we're talking about the relationships between two angles. This would be a supplementary relationship. You might recognize this. See how if you put these together, you'd have a straight line. This you may have seen vertical angles. We'll define both of those formally. First of all, we're talking about adjacent angles. Now, just the English word adjacent. All right, I want you to think of next to. That's what adjacent means. It means they're next to each other. Now, there are some conditions you have to meet. There aren't just angles that are near each other. They have to share a common ray, and the common side, which the side of an angle is a ray. They have to share a common vertex. Remember, a vertex is a little corner of the angle there. So, vertex of both angle 1 and 2 are right there. The vertex of angle 3 and 4 are right here. And these would be adjacent angles. Notice how they don't overlap. Angle 1 is, all this right here. Angle 2 is this area. This kind of the interior, at least, of this angle is right here. They don't overlap, and that's important. Same thing with 3 and 4. They're next to each other, share a ray, and they don't overlap. Vertical angles, I like to think of that as the across from relationship. So it's two things that are across from each other. And for instance, angle 3 and 4, like when you think vertical, you think up and down. Those are vertical angles, but so are angle 1 and 2. So you could say angle 3 and angle 4. We say that they are vertical angles, and they always occur in pairs. Same thing with angle 1 and angle 2. They are vertical angles. This is a little symbol for, I just put the angle symbol with an apostrophe S to shorthand for angles. So even when they're across from each other horizontally, they're still vertical angles. So really what it is your book defines it as angles whose two sides are opposite rays. Sometimes I like to think of it as, they form an X. You can see it that way. You can see it as two intersecting lines. That's another way to see it as vertical angles. And it's going to be no coincidence. Notice how angle 1 and 2 both seem to be acute. 3 and 4 both seem to be obtuse. It's no coincidence that those appear to be the same size, because they are. Complementary angles, those are angles whose sum, the measures, add up to 90. So here this is obvious if this whole thing's a right angle and you split this between angle 1 right here and angle 2. This angle here, if together they form a right angle is 90 degrees, then they're going to be complementary. But even if they're not touching, if you notice these values right here, if you take 47 and 43, when you add those up, you get 90. So the measures sum to 90 degrees. That's the only condition you need to be complementary. Supplementary, very similar, except they sum to 180. So the little mnemonic I like to use, so there's complementary, there's supplementary. When I think of like the C, you can think of like I could draw like a 9 with that C, and with the S I can make an 8 out of that S. So complementary is 90, supplementary is 180. That's one little mnemonic I like to use sometimes. If we want to find the supplement of an angle, well, let's see, this angle is 137. We need to know how much we need more, to kind of get a full straight line. Remember, 180 degrees is a straight line, so 180 minus 137. You can subtract those, you should get 43. So you could say the supplement of angle C is any angle whose measurement is 43 degrees, for instance. So we're going to talk about, try to identify some of these relationships. Anytime you see an angle, I like to highlight it. And I go from point to point to point. So here I go BFD, and then I'm also going to do CFD right here. If you notice, they're asking, are these adjacent angles? So is this statement true that these are adjacent angles? But notice here, remember how we said they can't share interior points? So both angle BFD and CFD, they share all of the interior right here. Even though they share a ray and they share a vertex, they're not supposed to overlap. That's how I like to think of it. So this is false. They're not adjacent, and it's because they overlap here. So we're going to say these aren't adjacent. They share interior points. You don't want that. Here you want to know if AFB and EFD are vertical angles. So let's see, AFB is there, and then I'll use a different color this time. E, F, D. E to F to D. Well, they seem to be across from each other, okay? And if you kind of drew just the parts that you care about, they almost form an X, but see how this one is a straight line here, but this one kind of goes crooked. So if this continued straight right here, if point E was right here, they would be vertical angles, but you can't have them just kind of hook across like that. So this is going to be, these are not vertical angles. So it's just as good to know examples that do work as there are that examples that don't. So these are not vertical angles. They're not formed by intersecting lines or opposite rays there. Alright, I'm going to see if these two angles are complementary, which means they add up to 90, or together they form a right angle when you add them together. I'm going to highlight A, F, E, and I'm also going to highlight the other angle, BFC, so from B to F to C. Now, just looking at that right here, I can't really tell if they're right angles. Can't tell if that's going to form a right angle, but they also give me the measurements. So if they give you that, well, all we need to know is that they add up to 90. If you add these up, you in fact do get 90. So you can just sum the measures to check when you're given the measures. We're going to check all of these statements. All right, AFE. I want to check to see if AFE and CFD are vertical. So AFE, and then I'm going to highlight the points CFD. All right, these appear to be vertical, right? They are across from each other, so that's good. And all you need to do is check to make sure that you have opposite rays right here. In other words, two rays that form a straight line. So that forms a straight line. That's good. This forms a straight line. That's good. So that checks out. So that means that this checks out. These are vertical angles. What about BFC and DFE? You want to see if those are supplementary. So here's BFC and then DFE. Okay. Again, we're given the measurements. So if BFC is 28 and then DFE is 118, I just have to add those up and check if they equal up to what. Remember, supplementary is 180. So I'm just going to add the ones digit, 8 plus 8, 16. I'm going to stop there. I know I can keep adding this, but you want it to be 180, right? If it ends in 6, I already know it's not 180. You can continue adding this. To see what value you get. You get, I think, 146, but I already know right there it's not going to be 180, so the second one is not true. All right, what if we want to check the validity of the statement BFD? Highlight that one, BFD, and AFB. I want to check if those are adjacent. Well, they have a common vertex of F. Remember, your vertex always in the center, so that's one qualifier for adjacent angles. They don't seem to overlap. See how they don't share any interior points? They only share this ray, which the ray itself isn't an interior point. They share that FB ray. So they touch on one side. That's good. They share a vertex. They don't overlap. So that checks out. These are going to be adjacent angles. Some things you can tell from figures, okay? One thing you can tell, if you have the congruence mark, you can tell if things are congruent. Of course, if they give you measures, you can compare measures to see if they're congruent also. So those things you can tell just by looking at them if they're labeled. Don't assume that two angles are congruent if you don't see the little markings or if you don't see the measurements. You can also spot vertical angles. For instance, I can spot that 3 and 5 vertical angles because it's easy to see if something's a straight line or not. Sometimes you'll have to trace over it, but you can tell those things. Adjacent angles are something you can spot, again, just by eyeballing it. You can see that things don't overlap. They share a side, they share a vertex. So notice all the consecutive, these are all the pairs of vertical angles. These all occur in pairs. Remember, there's not just one vertical angle. It's something is vertical to something else, something's adjacent to something else. 1 and 2 are next to each other, but so are 2 and 3 are next to each other. But you wouldn't say that 1 and 3 are not adjacent angles. See how there's this gap between them? So, but any consecutive numbers, 3 and 4 are adjacent. Angle 4 and angle 5, angle 5 and angle 1, those are all adjacent pairs. And then you have a few linear pairs, which a linear pair is a supplementary pair. Notice how 4 and 5 make a line. Notice how angle 3 and angle 4 make a line. Notice how if you these aren't pairs because it would take 3. Angle 3 and if you had angle 2 and 1 together, they form a straight line. But we wouldn't say that's a pair. Usually we're implying 2 there. But if you had a name for whatever angle 1 and 2 together was, that would be supplementary to angle 3. So just some things you can spot by looking at them. Again, I use that term linear pair. Break that down. It's a line pair. It's a pair, and we're talking about angles. It's a pair of angles that form a line. And it's going to be adjacent angles. So, you could say angle, if you look at angle ABD and angle CBD. And don't forget, you can change the order there. You can call this BDA, you can call this DBC. They form a linear pair. And we also can spot that if two angles form a linear pair, well, if they form a line is also we also sometimes call that a straight angle. You can see a line as a straight angle if you'd choose some point in the middle to be a vertex. Well, a straight angle is 180 degrees. So if these things make a 180 degree angle, then they're going to be supplementary. That follows from that. All right, so if we want to apply this, you'll see some homework like this. We have these two angles. If they say the angle KPL and JPL are a linear pair, I'm just going to sketch it. It doesn't have to be drawn to scale. And I'm just going to kind of get a picture of this. So we have KPL and we have JPL. So you can see J could be right here. They are a linear pair. That means whatever their measurements are, they add up to, they form a line right there, which is why I made this a straight line. So KPL, I'm going to put just 2x plus 24. That's the measurement of this thing. So that's just an expression for how many degrees it is. And then over here, I'm going to do 4x plus 36. Have the little degree symbol there. Now, we don't set these equal to each other because they're not. We don't know that they're equal. What we do know is that together they form a line, or together, same thing as, if you combine two things together, you're using addition. So if I add these two things together, I'm going to form a straight line. That's 6x plus, here I'm going to have 60. That equals, those two things add up to 180. So I've got 6x equals, if I subtract 60 on both sides, I get 120. So x is equal to 20. Now, I want to know the measures of these things. Well, is one of these 20? No, remember, x is 20. And then I can take that and plug it into each one. So for the measure of angle KPL, I'm going to do 2 times what I solved for x to be. So I got, this is 40 plus 24, that's going to be 64 degrees is the measurement of KPL. And let's do it for JPL. So the measurement of angle JPL is equal to, again, this could be 4. I'm putting this expression, 4x plus 36, 4 times 20 plus 36. So that one's going to be 80 plus 36, so it's going to be 216. So the measurement, oops, made a little jump there. The measurement of JPL, I'm sorry, what did I, 216. This is 80 plus 36, that's going to be 116 degrees. Now here's how you can check your answer. You usually can check your answer. They shouldn't be equal to each other, but we said they're a linear pair, which linear pair means it's supplementary and adjacent. So it's just those two conditions together. They form a line. You can confirm, look, 116 and 64, add this together, you will get 180. So it's reasonable that this is the correct answer. Last definition we'll cover, angle bisector. Well, we covered segment bisector in previous sections. It's something that cuts a segment in half. Well, instead of a segment bisector, it's an angle bisector. It's something that cuts a angle in half, and it's usually going to be a ray, right? I mean, technically, you could picture that. Let's say we had an angle. You could picture that a line could possibly cut an angle in half, but it's really just a part of the line that's in the angle that cuts it in half. So it's pretty much always going to be a ray that's going to bisect the angles there. So what it does is it's going to make, if you look at angle XAY, that's going to be congruent, and I'm going to put my equal sign with whipped cream on top, that's a congruent symbol, to angle ZAY. So those are going to be congruent there. And here's a sort of exercise problem, exercise where you might apply that. We have ray AC bisects angle DAB. It says if the measurement of angle DAC is 58, what is the measurement of angle DAB? Well, here's a problem. if you're like me, you might have trouble picturing this, so you might want to draw a picture first. Okay? So we have a ray that bisects this angle. It doesn't matter. It doesn't have to be drawn to scale. I'm just going to draw. There's my angle, and it's D, A, B, and I'm gonna make a ray bisect it. Notice how it's ray AC. Well, just instinctively, I didn't even, without planning, I just wanted to bisect it through the middle, and it happens to go from A, so that makes sense. So ray AC. So that means there's some point C. It doesn't matter where this point C could be way over here, right? Because ray, you could name it as long as it has some point along that ray in that direction. Then they tell us the measurative angle DAC. I see that would be up here. That's 58 degrees. All right, then they ask, you might think, oh, well, that means that this is 58 degrees because it cuts in half. So is our angle 58? Careful. They ask for the measurative angle DAB. So drawing a picture really helps you organize this information. So we're wanting to know the angle measurement of this whole thing. So obviously, if I wanted to get this whole piece, you could use the angle addition postulate, which is just a fancy way of saying you can add angles that are adjacent. You can add angles that are next to each other. So we got 58 and 58. You can add them that way, or you could do 58 times 2. Or if you're like me and you really like the distributive property, you can do 58 times 2 like this. So that's 100 plus 16. So that's 116. Don't forget your degree symbol. It is important when you're talking about the measurements of angles. And here's just something I want to point out before we finish. I didn't draw this to scale. There's no way this angle is 116 degrees. All that matters is that the picture helped me organize my information. 116 degrees would be at least 90 degrees, right? So 116 degrees would probably look more like this. This could be D, A, B. It could be this angle right here. But all you need to do is draw a picture to help you organize it. All right. That's the end of this part of the lecture. Yeah!
The views and opinions expressed in this video are solely those of Mr. Vogel and do not necessarily reflect those of the School of Sacred Heart, Agricultural, Board of Directors, Administration, Meeting Network, Sacred Heart Schools, or anyone else. Visit our website at shhkoto.org.